have to check what I wrote last time. Okay, basically it's what we are having here, right?
Yeah.
So in the end, we need, for the right-hand side vector, we need the B matrix and the stresses in Folk notation. So I think Alex wrote this hat for the Folk notation.
Yeah.
And if you want to implement it, you will have to add a minus here. Perhaps you remember from last time that Phoebe wants it with a minus. Given by Phoebe that it wants it like this. I explained it to you during the in-person exercise that you have to switch to the right-hand side, and this is where the minus comes into play. But it's, matter of taste. So basically we have these quantities which we need. B matrix here again, then we need the material and Folk notation. Again the B matrix, and then for the geometrical part we need the stresses, but now not in Folk notation but in tensor notation. And we need the derivatives of the undefined function with respect to the physical space. So basically these are the ingredients, and then last time, underneath only these quantities which you need and how you can implement them. So the question is, what is your specific question?
Yeah, I just wanted to check this. Like I have done till the right-hand side vector. I need to implement right-hand side vector.
Okay.
I just wanted to see where they are. And one more thing. Okay, cool. I will try, and if I get any doubt, I will get back to you.
Yeah, okay. So I can just demonstrate it to you if I start VPV now, and I can just type in calc, and then you see here the reduced output. So I got 1, 2, 3, 4, 5 iterations, but I only see the norm in the end. So not the whole. You see, if you just do tan, comma 1, you will get that with this current and tolerance values, and this is basically reduced. So you just get the residual norm here, and that's it. And here these lines in between, they just pop up if you do many equations. So it's just a guideline that you see, okay, Phoebe is still working, and it's just being here now up to 2000 equations somewhere. If you do really big problems, then one iteration might need multiple minutes or hours, and then you can be sure that it's still working, and you see the progress, how much time it needs. Of course, it's not that meaningful here with the small problems. And you see then here I got for the node now the value of 1.69, and then I just transferred it. I think it will be this one here. Then to the table. But of course you could think about any automation, but I'm not sure if I'm able to copy paste here. I never tried it. Okay, it's working. Perhaps you have to think to check if LibreOffice is able to calculate with these values. We'll just check. Oh, but it's working. So you could use just copy paste from there.
Hello, Simon.
Yeah.
Could you just go to the element file? I just wanted to clarify something regarding the right-hand side vector.
What do you need as the element? I have to check which.
Yeah, the element file, which we have in the Linux.
Wait, I think I will have to download it again. 1 second. Okay.
In the right-hand side vector, in the input for right-hand side vector, the input here it is requiring d wall, right?
You mean the subroutine here?
Yeah. The subroutine is requiring d wall, right?
Yeah. Just to clarify this, the subroutines is only if you have problems. Of course, you should implement the right-hand side on your own.
Yeah.
Okay, so, but here, basically, this right-hand side uses all these 4 quantities as an input, and it will output or write into P, which is then the right-hand side.
Yeah.
So these are all input.
Yeah, you explained me last time, like if I want to troubleshoot, I can do it.
Okay. I didn't remember that it was you. I remember that I explained it, but I don't know when and to whom.
Yeah. My doubt was like this devolve is for the integration part of it, right? We are using this devolve for the integration, if I am not wrong.
Yeah, exactly. Devolve is basically, you have to do it here, and devolve is...
No, not that. Like, you showed me notes, right? Your notes. No, just before. Your handwritten notes.
Okay, yeah. 1 second, where are they now? Did I close them, or is it here open? Yeah, we'll just reopen it. I have no idea where I put
It's
it.
open.
It's in the, okay.
Yeah.
I think it's below here.
Yeah, and also if you scroll to the top, this devolve is required because the right-hand side vector needs an integration over the element, right?
Yeah, exactly. Now I get it. Yeah, okay, these because we don't do the integral analytically, but numerically. And numerical integration procedure is now this Gauss quadrature, and this is why we need only evaluate these functions at Gauss points and multiply them with the Gauss weight or the Gaussian volume, however you want to call it. And this is how we just evaluate the integral not continuously, but only at discrete points, which are then the Gauss points.
Yeah. So basically, a simple tensor multiplication we have to code, and also we have to code this integration, right?
Exactly, but the integration is already done here. So it's just in this time, just the multiplication in the end with times devolve.
That's what I'm not able to understand. Like, why we are not doing the integration?
Basically, perhaps I can just Google it because it's...
Yeah, I know. I have studied this quadrature rule.
Yeah, okay.
We need, we directly use the values, we use the Gaussian weights, and we multiply with the devolve, right?
Exactly. If you look here for what's written here in the first line, basically, that's it. So we have a continuous integral, and we just do it at specific points. And our fx is now, what is in this case, B transpose CB. So this is our function, which we want to integrate in this point. And this is then only multiplied by a weight, within this, in our case, because we have this isoparametric mapping, this weight consists of 2 parts, the Gaussian weight times the Jacobian determinant.
Yes.
And this is then basically what we do. So we just have all our quantities which are within the integral and multiplied only by the weight of the Gauss point in the end.
Yes.
So devolve is in our case then the weight of the Gauss point.
Okay. Okay, devolve consists of both. Okay, that was my confusion.
Yeah, devolve is...
Yeah.
This here is only in one space because it's only from -1 to 1.
Yeah.
So this is basically what we do in our Gauss points are then defined within our triangle in parameter space.
Yeah. Actually, my doubt was I was searching for the Gauss points WGP, but now just I got it like WGP is included in the devolve, right?
Yeah, exactly. I hope we can see. Now I have to 1 second. So you get WG from here.
Yeah.
And then you just multiply it with
the determinant,
basically what's written in here in the end.
Yeah. Sorry.
And this is then the combination of Gauss weight times our other parametric mapping, which we need to take into account as well.
And what about the summation?
For this element, it's now basically simple because we have just one Gauss point. But of course, you need to do some summation. So we always do here pi I something is equal to pi I plus.
Cool. Now I understood it. Yeah.
Important, you don't have to initialize P and S. These are initialized to 0 within the element by Phi on its own.
Okay. Cool. Yeah, that was my doubt actually. I was searching for the Gaussian weights.
Yeah, okay.
Now I remember that they are included in this D1. Cool.
Okay, perfect.
And also, here because we are using a simpler quadrature rule, there is no need to write the summation. But if you want to use a better quadrature rule using 2 or 3 points, then we may need to write the loop, right? Like we may need to add.
It depends on how you construct your loop.
Yeah.
If I do now here just for the right-hand side vector, I probably will do a loop. If there's only one loop which goes, so the access every pi only once, then it's possible here to do it without the summation. But if you do some loop where you have to add or a summation either way, of course, then you need it. But if you need multiple Gauss points, you always need the summation.
Yeah. Cool. So we just write it for the general case, right here.
Yeah, I would suggest, because the next element which we want to use is a quadrilateral one, and there you have 4 Gauss points, and then we need it at the latest. So it makes sense to do it for the general case here as well now.
Thank you.
Yeah, you're welcome. Do you have any further questions? One basic information, because some other students in the other lecture asked me. Of course, you can write your questions in the board on Moodle throughout the holidays as well. I can't promise that I will look after it on a regular basis, but of course I will be online a few times throughout the next 2 or 3 weeks to check, and if these questions are quick to answer, I will do it. Of course, if you have big questions, perhaps I will skip it after the holidays, because I'm on holiday too, but usually continue asking questions. Perhaps some fellow students of you can answer it before me, so you can just work on if you didn't finish it now before Christmas. But it's really helpful if you do this element on your own and understand it before we go on then, because when we go now to the mixed method, as Alex told you, the implementation will be a little bit more complex, not too complex, because it's always based on what we're doing now. So you will actually get this reference solution, which I will upload tomorrow or the day after, every time for the following exercises to extend it. So we won't build a whole new element, but more modify the element in the future, because this is what we, when we implement new elements, you always start with an old, simpler one to extend it. You never do a whole element by scratch usually. You just take an old one, modify it, and try to get it working. And that's what we want, or that's what we want to do in the following exercises as well. So the element which you are doing now is the basis for all the following works we want to do. So that's why, please, if you don't finish it before Christmas, take the time afterwards, but that we can, let's say in the third week of January, when we have perhaps the next exercise, can really go on working then with a little bit more complex implementation.
Hello, Simon.
Yeah.
Do we have the consultation hours this week? And if we have them, when do we have them?
Nope, since I'm on holiday from Wednesday on. So there won't be an additional meeting, but as I told you, please then write it on the board if you have further questions. And I will hope to answer them as fast as possible, but I won't be online every day. So, but yeah, I can't promise you any dates when I'm online. So just write it on the board or write me an email, but better always on the board, because then everybody can see it and perhaps answer your questions independent from me.
Thank you. Thank you, sir.
You're welcome. Okay, I would say I will wait 5 more minutes if some question pops up. And if not, then I will wish you happy holidays. But first of all, I will wait 5 more minutes if you got or find any more questions. We'll upload the solution. I think tomorrow or Wednesday at the latest.
Hello.
Hi.
Yeah, one last thing before go. Is there any operator for transpose, or should we write the code for transpose?
I think there is no specific command. So basically, you just usually use it within a loop and then switch the indices.
Thank you. Thank you.
Are there any further questions? Because if not, please use the Moodle board if there are any further questions, like Meatlash wrote as well. And yeah, with this, I wish you happy Christmas and nice holidays, and good New Year. If I a little bit early, but it's fine. And then I hope we'll get a fresh start in the new year, then with new elements to implement. Then nice holidays, have a good time, and see you in 2021.
You're locking. Locking. क्या कर रहा है?
You are currently the only person in this conference.
أقول إيش خلصوا